Okay, pre-calculus, in this video we're going to be, we're still in Unit 6, which is trigonometric graphs. So in order to graph our trigonometric functions, we need to understand how the equations transform and what impact that's going to have on our graphs. So just like we talked about transformations with our beginning parent functions in the first of the year, we are now going to talk about transformations involving our trig functions because they are a little bit different because of the nature of the graphs. Okay, the first thing we want to do is define what the period means because there will be a value in our equation that tells us what the period is. This is just the length of a full cycle. Well, what does that mean, Miss Griggs? In other words, it is the length, whoa, out of control. It is the length of this right here, okay? That is a full cycle of either the cosine or the sine graph. So it is a whole wave up and a whole wave down. So you've got a peak and you've got a trough. That is pretty much what a full cycle is. And depending on what the period is, it will depend on whether it's stretched out or something like that. So that's what I mean by the length of a full cycle. All right, the other thing that is important is, and new to us, is the idea of the amplitude. Well, the amplitude is the height from the middle to the top, and it's also the height from the middle to the bottom. What does that mean? Well, using top and bottom is not really mathematical, but it's easier for you to understand. So let's say we're on the x-axis and we have our sine function just like that. Well, the amplitude is going to be the measure from the top to the x-axis. So this right here is my amplitude. So if you'll notice, we also have the amplitude here. Okay, that is what your amplitude is. It just tells you how tall the wave, if you want to think about it that way, how tall it would be from the middle, that would be this right here, to the top, and from the middle to the bottom of the graph. That's what it tells me. Okay, so let's go back to this equation right here. This equation is just a basic equation set up so you'll understand all of the values. If you have a constant added at the front or at the end of the equation, that represents a vertical shift. So that just means up and down. Vertical shift. Okay, this sign right here, if it's negative, we have a reflection. If it's positive, it doesn't mean anything. It just means we don't have a reflection. If there is a value in front of trig, now when I say trig, I mean cosine or sine. So if there's a value there, if there's nothing there, it's an understood 1. But if there's another value there, you're going to know what that, well, the values mean the same thing. It's the amplitude. Sorry, I'm misspeaking all over the place. If the amplitude can be any value. It can be a half or a fourth or a 7 or a 3. It can be any value, all right? And so the trig, of course, for our transformations, we're going to be dealing with sine or cosine here. And then if you have a value between your trig and your other values or your parentheses, that, of course, is going to be the period. And we'll talk more about that in a minute because that is a little trickier. And then, of course, this value right here, it can be theta or it can be x. Theta tells you it's in degrees. X tells you it's in radians. And then, of course, the C right here is going to be, if it's in parentheses, that means that we're going to have a horizontal shift. In trig, we also call this a phase shift. Okay, so that's what I'll refer to it as a phase shift. So now let's see what this is going to look like in an actual equation. So we're going to look at example 1 here, and we're just going to read the graph from or the equation from left to right. So we have a positive 2 here. That means that we are moving up 2. This 2 could be at the end. So you could have seen this written this way. So y equals -3 sine 1/2 times theta minus 4 plus 2. So the 2 could be at the end of the equation or at the beginning. Okay, this negative here tells me that I'm going to reflect. The 3 means the amplitude is equal to 3. We are dealing with the sine function. 1/2 is the period. Okay, so the period of the parent function for sine is 360 degrees, or 2 pi. The reason I'm using degrees is because of theta. All right, so that is what the parent function period is. But since there's a value here other than 1 in my equation, I have to divide the parent period by 1/2. So that means that I've got 360 over 1 times the reciprocal of 1/2, which is 360 times 2, which is 720. That just means it takes more space to carry out that full cycle of the graph. All right, this -4 here means that we move to the right 4 spaces. Since that's in parentheses and it's a negative, that means you're moving to the right, just like it did when we were talking about our other parent functions. Okay, let's look at example 2. I'm going to switch colors here. All right, keep in mind this -1 at the front. You could have written the equation this way. Okay, it could be at the end, so please pay attention to that. This indicates that we are moving down 1, out of control. Down 1, there is a reflection. This 2 right here tells me that the amplitude equals 2. We're dealing with the cosine graph. The period of the cosine graph, well, the parent is 2 pi. So I've got to divide that by pi. So it's 2 radians. That's what the period would be. We're dealing with x here, so that means we are dealing in radians. And this +3 means that it is moving left. 3. Okay, so what we're going to do in another video, we're going to go on to explain some of this stuff in these examples right down here.